Hi everyone, what's up? All good? Great. So today we will be solving the question palindromic substrings. Let's see what is this question. Given a string S, return the number of palindromic substrings in it. Okay, we are given the string S and we need to return the number of palindromic substrings in it. Okay. And a string is palindrome when it leads the same backward as forward. What is a palindromic string? When we read it from backward or forward, it will be same. It is a palindromic substring. Okay. So a substring is a contiguous sequence of characters within the string. Okay. You all know what is a substring? It is a contiguous sequence of characters within the string. So let's see how we can solve it. Okay. We need to find the number of palindromic substring in it, right? Yeah, okay. So, first of all, what we can do, we can simply find all the substrings and check for them whether it is a palindrome or not. Then we will be able to check how many substrings are palindrome in it. Okay, right now, let's see. So, let's see the substrings in this. Okay, so one substring will be A, one will be, three substrings will be A. Okay, this A, this A, and this third one. These three will be separate substrings. Okay. And one substring will be this AA, and another substring will be this triple A, 3 times A, and another substring will be this AA. Okay. So at the end, we will be having six substrings in this. Okay. Now, what we can do, we can check whether these substrings are palindrome or not, so that we will be able to get the count of palindromic substrings in a string. Simple. Very good. Okay. So now let's talk about the time complexity. So, as you know, for finding all the substrings of a string, what is the complexity? It will be n square, right? Yeah, I will also tell you how. Just give me a minute. And now for checking whether it is a palindrome or not. So it will take big O of n because we need to check for all the characters whether this character matches with the first one, whether this character matches, so and so on. So this will take big O of n. So it means the overall complexity of this approach will be big O of n cube, right? Okay, doesn't seem so good. Okay, but for now, let's keep it. We will optimize it soon. So now let's see the code for this when we are finding all the service strings and then checking whether it is a palindrome or not. Okay, so first of all, I am initializing a result variable 0. Now I will be iterating through all each character of that string, and then I will be iterating through each subsequent character of that string. I am assuming that you know how to find all these substrings of a string. Okay, so first of all, we are at, let's say we are at A. We are at first index. Okay, so first of all, we are at first index. Okay, now we will check for A, and our temp is A. Okay, cool. Now our temp is A. Is it a palindrome? Yeah, it is a palindrome. Okay, cool. So I will update my result variable. Now we will check for another character. This one, it will be added in the temp. Yeah. Is it a palindrome? Yeah. So yeah, I will update my result. Now I will add the third character in the string. Is it a palindrome? Yeah. So I will increment my result. Okay, so now as the size of this string is 3, so we will come out of this loop. Now again, I will be 1. So now we will again initialize our temp variable with s of 1. Okay, cool. Now s of j, okay, which is s of 1. Now is it a parallel? Yeah, so I will update my result. Now s of 2 will be added to the temp. Is it a parallel? Yeah, cool. So I will increment my result. Now I will come out of this loop. Again, I is equals to 2 and j equals to 2, and I will again initialize my temp string. And is it a parallel? Yeah, it is also a parallel. So I will implement my result and now come out of this loop, and I is equals to 2, which is less than 3. Now this loop will also get ended. And finally, we got our count of substring, palindromic substrings in our string. Got it? In this way, we are going through every substring and checking whether it is a palindrome or not. So these two rules we take n of n squared, and for checking whether it is a palindrome or not, we take big O of n. So the overall complexity of this code will goes to big O of n cube. Okay. Now let me tell you the code for palindrome as well. So we are initializing I is equals to 0 and j is equals to the end of the string, and checking for all the characters whether they are equal or not. If they are not, then we are returning false at that point only, because we don't need to check for further characters. And if they are equal, then we will be checking for further characters. Okay, very good. But now this approach doesn't seem so good, as it is taking big of n cube. So what we can do else? Okay. So like if we take, if we consider this character as the middle character of the string. Let me tell you how. Okay. Suppose this first character as the middle character of the string. Now, obviously, if there is only one character, then it is a palindrome. Okay. So now we will check for left and right characters to that character, whether they are equal or not. If they are equal, then yeah, we know we have found one more palindromic substring. So in this way, by assuming the character, assume that at the character at which we are, assume that to be the center or to be the middle character of the substring. Let's see by running what I am saying. So let's see, I am at A. I am at 0 at index. Okay. Let me just give a second. Yeah. So I am at 0 at index for now. Okay. So now I am at E. Yeah. Now, yeah, as it has only one character, so yeah, it will be a palindrome. So I will increase my result. Now I will check for the left and right characters, whether they are palindrome or not, whether they are equal or not. If they are equal, then yeah, I have got one more palindromic substring. Yeah. So, but in the left of this character, there is no character. So we can't do this thing for I equals to 0. Now we will go to I equals to 1. It is also the same character. And yeah, as it is only one character, so we will increment our result. Now I will check for the left and right character of this character. Yeah, so this character and this one. Are they equal? Yeah, they are equal. So it means this is also a palindromic substring, and we will increment our result. Okay, cool. Now I will check for more subsequent left and right characters if they are there. But as it don't have any subsequent left and right character, so we will not check for them. Now we will come at I equals to 2. Oh, sorry, my bad. I have removed the result as well. Now we will check for I equals to 2. As it is only one character, so it will be palindrome. We will be incrementing our result. Now we will check for the subsequent left and right characters, but as it does not have any right character, so we can't do this. Okay, but can you now guess what we have missed in this? You can simply see that our result is 4 here and our result should be 6. So I think now you have guessed which substrings, which substrings we have missed. And if you haven't guessed it now, so just take a pause for a second and think about it. Then come back to the group. Okay. So we have not considered any even length string, which is made by the 0 and 1th index character and 1 and 2 index character. We have missed these strings with this approach. Okay. So what we can see, what we can do in this, as we are incrementing, as we are checking for the left and right characters to this character. So, okay, so we will do this thing. We will don't make any changes to this thing for the odd length service string. But for taking the even length service strings, what we can do is we can initialize our left character to this one and our right character to the character right of that character. Now we can check if they are equal. Yeah, so I will check for the subsequent left and right character. Okay, so in this way we will be able to grab the even length service palindromic service strings as well. Now let me show you the how we can code this approach so that you will get much better idea. Okay. Yeah, so first of all, I will be storing the length of the string in and initializing a result as 0. Now I will be iterating in the string and now I will be checking for the left and right characters, considering that character as the middle one. Okay, so int L is equals to I and left is equals to I and right is also equals to I. Okay, and till when we will run this loop? When L is greater than or equals to 0 and then R is less than N. This will be the base condition. And if S of L is not equals to S of R, if they are not equal, then there is no point of checking further. So we will simply break them. Otherwise, we will be incrementing our result as we have found a palindromic substring and we will be checking for the subsequent left and right characters by L minus minus and R plus plus. Now this is the case for even odd line substring. So what we can do for even line substring is we can initialize the left with I and right with I plus 1. So in this way, we will be able to simply grab the even service. So the same code goes for here as well for L is greater than or equals to 0 and R is less than N. If S of L is not equals to S of R, then we will simply break it. Otherwise, we will implement our result as we have found the palindromic solution and L minus minus and R plus 2. And at the end, finally, we will return our result. Okay, so let's try on this. Okay, sorry. I have just initialized the timer instead of running. Yeah, it's working fine. Now let's try submitting this. Yeah, it's working fine. Now you can see that there is a kind of code duplicacy here. So I can simply condense it in another function void count palindrome, and I will be passing S, string S, integer L, and integer R, and integer result as well by address. Okay, so I can simply, okay, now I record it here from palindrome S, L, R, and result, and the, I record it again here, so it will just decrease our code duplicacy. Okay, yeah. Now let's run this again. Okay, we need to declare n here. This will be a mistake. Yeah, now it's working good. Okay, so now let's talk about its time and space complexity. Okay, so now talking about its time complexity. As you can see, we are running on one loop for going for each character and checking for the left and right. And for checking for the left and right characters, it will take big of n. So its complexity will be reduced to big of n square. Big of n square, right? And it's talking about the space complexity as we are not using any extra space. So its space complexity will be big of 1. Okay. I hope you get this question. It was not that necessary, but yeah. The brute force is quite simple that we just need to go to every service string and check whether it is a palindrome or not. So yeah, it was a medium level question. I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.